Welcome back to Math Methods. This is an asynchronous session, which means that you're going to be interacting with these materials on your own. In particular, we're going to be developing some notions of prenumeration. We're going to be taking another look at the infamous horse problem, giving you a few things to think about in terms of pa and ma kettle, and also reminding you of a chapter in the text that you're going to be able to need to read. So that's our general overview. We're going to first now go and take a closer look at our model of learning. This video is going to talk about the action on objects framework. This is the model for learning that we'll use throughout this course, and it can be expressed fairly simply. Basically, we select an object for the students to interact with, and then based on that interaction, mathematics will emerge. So let's take a closer look at some of the intricacies of how that might work and how it's set up. As we look over here, you'll notice that there's different types of objects we can look at. We can look at a manipulative object. We can look at a sketch object. We can look at a mental picture object, and we can consider an abstract object. Now, for our purposes, since we are teaching in the kinder through 6th grade realm in this course, our objects of choice should be at the manipulative or the sketch level. The mental picture and abstraction, although perfectly fine objects, are more for middle school and high school, and so we won't be spending the same degree of emphasis on that. When we think developmentally, a manipulative really is something that we can physically touch and can handle and can manipulate. We can be very creative in terms of what manipulatives we try to use, but remember, when you select a manipulative, it needs to be safe for the children, it needs to be low to no cost, and it needs to reflect the mathematics. As long as it meets those 3 criteria, you should be fine in terms of manipulation. When we think of a sketch, this is a little bit trickier. And in particular, what we want to have happen at the sketch level is we would like to have it so that the students, first of all, have the vocabulary in place. This was a real problem in the early days where people would be asked to use manipulatives that they weren't aware of what they were. Case in point, you don't have to be overly elaborate in terms of how the vocabulary is developed. It can be very informal. There was a study at the Reading Center when I was there that the researcher asked the pre-K students to bring them a fuchsia tray. No one in the group knew what fuchsia was, and so they trot back and one little student brings up a tray, and of course it's the wrong color. And so Dr. Raphael says, no, not that one. I want the fuchsia tray. It's the one over there on the far end. And that was the total intervention. Well, 6 weeks after the class was over, every child in that group was able to identify fuchsia correctly. And so we don't have to go into great detail here, just enough so that if I, as teacher, ask you to do something, you are able to follow up with the instructions. That's what we're talking about here. Do you have enough knowledge of the material so that if I have you pick one up, you'd be able to identify it? At that point, as teacher, I'm going to ask you to do something. Maybe our object is a horse. Maybe I'm having you buy and sell the horse a number of times. And then you're going to organize your work and build a record of that action. This cycle is extremely important, but it relies on vocabulary. So the very first things we have to do is we have to make sure that vocabulary is in place, that we understand what we're acting upon. Then we do something, we have an activity. As teacher, I will help you organize the results of that activity. And that record of action, in many cases, is the formal procedure. As we'll learn when we see fractions, decimals, operation on numbers in general, the record of action is the procedure. Now, in an ideal world, self-posed problems would also be used. And in a self-posed problem, the students themselves are coming up with the activities they are probably going to recreate the same type of organization, with the result that the record of action they create will give rise to some meaningful mathematics for them. In looking at this, since we are early childhood through 6th grade, manipulatives will be kinder through 3rd grade. That's a good rule of thumb. 4th through 6th grade will be sketches. And really, we do not want to mess around with mental pictures through abstractions. That's more for middle school and high school, university, respectively. You'll notice, though, that regardless of which of these objects to think with, the teaching cycle is going to look the same. And so let's take a look here and see what that teaching cycle might look like. I'm going to pull up a pen so that I can actually make a few notes here. Let's say that we're working with manipulatives. Very reasonable place to be is for us to start thinking at the manipulative level. And in doing that, we have generated some vocabulary. So we've covered our bases here. The students are aware of what materials we're working with. We have them do something, and then as teacher, we help them organize their work and develop the record of action. That's a complete teaching cycle. So everything from here to here represents a complete teaching cycle. And if that's as far as we go in a single cycle, I still feel quite good. Again, in an ideal world, it would be nice if they had self-posed problems, but that's not always going to be taking place. It often depends on time. We can use manipulatives, we can use sketches quite effectively. The teaching cycle is the same. We will generate vocabulary for the sketch. We will act upon the sketch. Now that sounds a little odd, but when we go through fractions and rational numbers, I think you'll see it's much easier than you might expect. We will organize the result of that action, and the record of action becomes the mathematics that we're going to be exploring. Same thing can be done with mental pictures. Same thing can be done with abstractions. So if I'm teaching kindergarten, maybe my objects of thought will be centimeter linking cubes. If I'm teaching graduate studies, perhaps my unit of thought will be a function. But in either case, we develop vocabulary, actions, organizations, record of action, with the result that mathematics emerges. We will revisit this a number of times throughout the semester. So if you don't feel like you're totally comfortable with it yet, don't worry, we'll have plenty of opportunity to review this. This is the model, however, that I'll be referring to throughout this course. So when we talk about action on objects, we really are talking about first selecting what developmentally is an appropriate tool for our students to think with. And for this class, that will be at the manipulative and the sketch levels. Once it's identified, we will then have problems. And so a good problem, like the horse problem, is extremely powerful in that it gives us the opportunity to explore together, to develop discussion, to develop vocabulary, and to think about this so that the math that emerges can rest on a solid foundation. We'll do some actions, we'll do some organization, we'll build some record of action. We will repeat this enough throughout the semester that by the time you're out in the classroom on your own, it's almost second nature. Now that we've had the chance to review the action on objects framework, I'd like you to see how this plays out in developing numeration, in particular, the pre-numerative ability to visually recognize digits from 0 through 9. We're going to be making use of subtizing and chunking, as we'll learn a little bit more about here in just a moment. And we're also going to have a chance to review the objects and how acting upon objects can help in this endeavor. So what I'm going to have you do at the end of this particular video is to open up your Blackboard shell, go to Course Content and Module 1. You should have access to a subfolder called Subtizing and Chunking, and within that there will be 3 discussion and demonstration videos I'd like you to watch. There are 3 other videos there that are review. So after you've seen the discussion and demonstration video, you can go back and just watch those videos kind of as a quick review and a refresher so that you'll be able to capture the main ideas when you want to move forward.